Welcome back, everyone. My name's Andy. This is the Coding Dojo. This time we're going to be doing the Fizzbuzz Kata again. Um, Last time we came up with a solution, but when we looked back at it, um, there's some things that we think we could have done better. So, for instance, we have our code here. Here's our solution. Um, it's kind of dense, but the biggest problem is that if somebody wants to change the requirements, we have to come in here and change our code. So, for instance, if they wanted to add a third rule, if they wanted to add whiz, um, then we would have to come here and add whiz. And well, what if they wanted fizzbuzz and fizzbuzz whiz? That would of course um, take um, more work. And what do we um, copy and paste and then edit one and not the other? That's just a kind of a code smell. The other thing that we didn't really like is our way our tests kind of came out. Um, I'm actually fine with having multiple tests for something like um, fizz instead of multiples of three. Um, One of the problems with a problem like this is you can't test all. I mean, you can't test all of the numbers because then what if somebody says, well, instead of from 1 to 100, what if we go to 1 to 1,000? Well, you're not going to write tests for all of those, and so you do have to kind of spot check. Then if you find bugs or something like that, you add to your tests. But these tests are kind of confusing. The fact that you have to know the index, um, seeing these two numbers, somebody could come in here and not really understand what is being tested. So um, with that, let's go ahead and jump in. So again, just to reiterate, we're going to do the Fizzbuzz Kata. That says, write a program that prints the numbers from 1 to 100, but for multiples of 3, print fizz instead of the number, and for multiples of 5, print buzz. For numbers which are multiples of both 3 and 5, print fizzbuzz. And this gave us some examples of what would happen if they added whiz for 7. So those are the kinds of things we're going to keep in mind as we do this. So we have our base function set up. We have a test set up. We have our tests running down below. Right now our failing test is failing. One difference from last time is instead of running just watch, we're running just watch all. That will run all of our tests. Just watch cut some of the tests out if they aren't from this change set. So it looks in Git to see whether files have changed and tests have changed. But we want to run everything. That's the watch is more of an optimization for when you have a big project and um, lots of tests checked in. Um, so very similar to last time, we want a test to make sure that we return an array. And so we expect, when you call fizzbuzz, let's see. So one of the differences between this and last time is, let's see, to be array, I believe is what it is. Okay, expected value to be an array, received undefined. So one of the differences between this and last time is we're still using jest, but we brought in this jest extended, which is a package, and it has some more matchers, including some around arrays. So just bringing in that package lets us write something that's just a little bit cleaner and just tells us what we want. It's just more explicit about what we want. So we have our first failing test. And let's go ahead and make it succeed. Okay. Now we want, again, to return numbers. Not a... Okay, and so we expect Fizzbuzz 0, and our editor was being helpful. To be 1. So again, here we have our same syntax we didn't like before. But let's roll with it for a little bit, and we'll go ahead and refactor in a second. So values equals array. So we go ahead and return our array. And then we go values push. Oh, there we go. Let's go ahead and add another one. To be 2. So now again, like before, we're going to go ahead and go into our loop. Starting with 1, going to 100. We're going to go ahead and increment it each time. We'll go ahead and move this up. And push I. So our code on the left pretty much does what it does. There's not a lot to improve upon there. But over here, we don't like this. So let's think of a different way we can look at this. I think what we would want to do is we'd want these numbers to match up. I think that would get rid of a lot of confusion. So another thing we're doing here is we're running the same function over and over again. So this first line goes and generates 100 numbers, and then this first line generates 100 numbers, but this one only looks at one line, and this one, or one number, and this one only looks at one number. So that's an inefficiency. That doesn't really matter for runtime and things like that, but it is a little bit messy. So let's think about for our tests, let's run our Fizzbuzz once, and then we will go ahead and compare all the numbers that we care about. So let's start off with creating a variable. We'll call it values again. And we want a before each. So this is a function that's going to be run before each of our tests. And let's go ahead and say values equals Fizzbuzz. And then instead of this, we're going to expect values to be array. Okay, you need to spell before correctly. And now let's go ahead and we'll do the same thing here we can replace this Fizzbuzz with values. Oh, we get rid of the function. So we've made one refactoring where we've pulled this out. Now we're only running it once per test. We could make it run once overall, but I think once per test is kind of the way I like to do things. That way each test is starting nice and clean, but then you can test all the things you care about. But that doesn't really solve our problem here where these numbers are kind of mismatched. So let's go ahead and create ourselves a function. Let's call it Fizzbuzz 4, Fizzbuzz of. Let's go num, and we'll return values num -1. So let's say we're looking for the first number. If we pass in 1, we will actually look at the 0 index. So if we want to know what the third number is, we will use we'll pass in 3. It'll look at the second one, which will be the third item there. So let's try that down here. So if we do Fizzbuzz of 1, we expect it to be 1. Fizzbuzz of 2, we expect to be 2. Let's go ahead and we want 4 to be 4. And let's go big. I think last number that isn't divisible by 5 or 3 is 98. We'll see if we make the same mistake I did last time with 27. I could pull out a calculator, but okay. Returns numbers if not multiples of 3 or 5. So we take the Fizzbuzz of 1 is 1, Fizzbuzz of 2 to be 2, Fizzbuzz of 4 to be 4. So yeah, I think that's working out a lot better. And then I think we can put this function either at the top or bottom. It's probably better to have it be up top and obvious to everybody. So now let's go ahead and move on to our next test. So our next test is we need to make sure that on 3s we return a fizz. A multiple of 3. Okay, so we expect Fizzbuzz of 3 to be fizz. Okay, so down on the lower over here we see we expected fizz, but we got 3. So now we need to go ahead and we're just going to do the exact same thing we did before. So we're going to say if I is, we'll say if it's a multiple of 3, evenly divisible by 3, we're going to say values dot push fizz, else Okay, so that passes. If we go ahead and do expect Fizzbuzz of 9 to be Fizz. And let's go ahead and do a couple more. Let's do our favorite 27 and 99. So those all pass. So the next thing we want to do is for multiples of 5. So we essentially want to do the same thing we just did. Buzz in a multiple of 5. Okay. And so we expect Fizzbuzz of 5 to be Buzz. Okay, so if we go over here, so we can't just write this next line right in there, but this feels like we're falling into the exact same track we did last time. So we have this function where now we're just we're editing it as opposed to expanding on it. So we are we're not following the open close principle. So we are basically going in and editing things as opposed to extending them. So let's go ahead and back this test out for a second. We'll go ahead and comment that out so we can refactor while all the tests are passing. So we want to refactor on green and not on red. That's a good habit to be in. So not always. Sometimes you'll see small refactorings that I won't do that with. But so for instance, earlier you saw me pull out values into an array without going back and making my tests green. If it's more complicated than that, then I won't do it. But if it's something simple, that's what I do. So how can we pull this out? So one of the things we talked about last time briefly is the different rules we have. So we have this rule that if something's equal to 3, then we do this, and if not, we do something else. And now we're going to add another rule, Buzz, and in the future we may have more rules. So we kind of have this. So there's this idea that we're talking about that is a rule, but it's not in our code anywhere. So let's go ahead and put it into our code. Let's go ahead and say our fizz rule equals so our rule kind of has two parts here. One is how do we know that it matches, and then what do we put on instead. So let's start with something called matches. And let's go ahead and make that a function. Let's go ahead and say you pass in the number. And then it returns if num is evenly divisible by 0. So that should return a bool, true or false. And so let's go ahead and try that out here and say if fizz rule matches I. Okay. So that we know this is passing for all of our fizz rules. And let's go ahead and give it a value. We'll call it value for now. That may not be the best name, but sometimes it's hard to tell what the right name is until you get into it. So we have our matches, then we'll go ahead and use our fizz rule value. So our tests all pass. So now we've extracted our rule out. We have a thing called a rule, but it's not easy to add to those. So let's go ahead and so fizz rule and is hard coded. Let's go ahead and take that hard coding out. So let's go ahead and say let's actually gonna go and make this rules is an array of rules, and inside there we'll go ahead and put this rule. And let's go ahead and comment this out. And so now we want to loop through our list of rules for what? Actually, we can go. We'll start with a for loop, and maybe we want something different there. Maybe we want like a use a for each, or but let's go ahead and just start. We'll start at 0 while rule is less than rules dot length. Then we want to do our rules dot rule dot matches I. So if then we want to do our rules rule dot value, and we want to push that onto our array. Okay. So that works for our first part of this if. But it won't work for our else. So let's change this around a little bit. Let's start with, we'll call it result. We'll go ahead and let result equal an empty string. Then instead of putting it onto our list, we'll go ahead and say our result plus equals our rules.value. Then if nothing's been put into result, then we want to put the number in there. So let's go if result is that, else we'll go ahead and push our result. Else if, sorry. And we're missing a bracket there. Okay, what is this complaining about? What's going on? Oh, we don't want else if, we just want else. Okay, so that worked. So now we have a list of rules that we are applying. Looping through our numbers, and then we're applying all of our rules, and then if they are if any of the rules have been applied, we use them, otherwise we push our number. So this works, but I think it could be a little bit cleaner. So what if we change this out and used a for each instead? So if we do a so on our rules, for each, we do a function where we have a rule, then this becomes if rule matches I, result plus equals rule dot value. Let's try that. So that's the same logic. I think it's a little bit cleaner. We remove that rule dot, the rule dot. So that's one less thing that somebody has to understand when they jump in here. So that's definitely an improvement. So we go through these rules, and if none of them work, then we push our number, else we do this. I think it will be better if we reverse that order. So if it's not empty, oh, sorry. We'll go ahead and bring this up here and this down here. So our So we're going to test our rules. If our rules were used, we're going to put that on the list. Otherwise, we will push our number. So we've done a bunch of refactoring. Let's see if it makes our next test easier to write. So we'll go ahead and uncomment this. So we expected buzz for 5, we didn't get it. So let's go ahead and add another rule. So when num is evenly divisible by 5, we replace it with buzz. Okay. Num is not defined. Okay, so we have to make sure we spell things correctly. There we go. And so let's try a few more. Oop. So 10 should be buzz. 25 should be buzz. 100 should be buzz. Okay. So again, now we're solving the problem. We're not solving it the exact same way we did last time, and that's fine. That's actually the purpose of this. At the end, we'll compare this to the way we did things previously and see if we like this a little bit better. I'm going to change this so it says returns. So a couple times, so this is called value. Value is a very generic term. And as I was talking, I was using the word replacement. So let's go ahead and change this to replacement. Okay. So matches. So we have a rule with a replacement, a rule matches, match, criteria. Yeah, let's try criteria instead. So if we meet our criteria, we replace the value. Okay, haven't made a mistake with that. Okay. Now let's go ahead and do our Fizzbuzz rule. Multiple of 3 and 5. So do Fizzbuzz of. The first one should be 15. That's actually 5 times 3. Just did that right in my head. And this should be Fizzbuzz. Fizzbuzz is not defined. Oh, yep, we want that to be a string. And that passed. So that was a difference between the way we did things this time and the way we did things last time. So last time we said if it was 3, we use fizz. If it's 5, we use buzz. So we had to make a rule if it was both. But here we have these rules and we apply them in order. And if the criteria is met, we add it to the to a string. And then once we build up that string, we go ahead and pass it off. So we kind of get this Fizzbuzz logic by default. So 60 should be there as well. Yeah. So that works with all of our rules. So let's look at, let's go ahead and go back to our Fizzbuzz here. We'll go ahead and move this back over. Is the code you've written clean? Well, there's certainly more of it. Did you refactor throughout or do it all at the end? We refactored throughout. What if a requirement came along that multiples of 7 were whiz? Well, we would just have to add to this list. So that's still coming into this code. So really what we could have done is split these up into smaller functions. And so for instance, we could pass in the rules, and then this function wouldn't have to change. So we could get that just by extracting these into separate functions with variables that come in. So we could have a variable for how big we want the number to be and what we want the rules to be. So what would we call that, a function like that? Well, we're doing number replacement. Well, let's try. Sorry, we'll call it. And we want the max number and the rules. And so let's go ahead and rules for each, okay. And we want to, so we'll need our own values down here. We'll go ahead and return values. And so a lot of this just kind of goes away. So we can go, let's go ahead and do this. And so now we want to return we call it? Number replace 100, and our rules. So that all passes. So let's go ahead and implement that case where we wanted to add whiz. So let's think about that. So we have number replace. Let's say we had our fizz rule. Okay, and let's say we had our buzz rule. So our rules are fizz rule, buzz rule, unexpected token. Yep. Okay. So here we have our function fizzbuzz. We have our rules, return number replace 100 rules. Let's say we wanted to implement a fizzbuzz whiz. So normally I would spin up another test file, but we're just to mess around real quick. Let's say let's go. We'll go. And we'll go const values equals fizz buzz whiz. Okay, so this isn't going to work. We don't actually have that function, so it doesn't know about that function. So let's go ahead and come up here and define it. Actually, let's go ahead and export a fizzbuzz. Let's go ahead and just export that real quick. Can we just do this? This is not a function. Okay. Fizzbuzz. Let's go. Does this? Sorry. had some audio that started kicking in. I don't know if you guys could hear that or not. Okay. Okay, so we're breaking Fizzbuzz. Okay. So, normally I would only have... let's look up real quick, see how... see what Stack Overflow has to say. Okay. Oh, we are in the wrong file. We are on our first attempt. There we go. So if we go ahead and... So for Fizzbuzz, use Fizzbuzz, and for Fizzbuzz Whiz, we export those. So Fizzbuzz is not right, so we want Fizzbuzz. So we'll say this is our module. Const Fizzbuzz equals module dot Fizzbuzz. Okay. Okay. Well, I'm doing all this to avoid bringing out splitting things up into multiple files. Let's just we'll just take it back to the way it was. And so ideally we'd want to pull these things out into different modules, and then we would compose things a little bit better. But for now, we know that if we just brought this in, and then added a whiz rule, and went ahead and wrote a whiz rule, then we could just keep adding rules. Also, this talked about, well, what if we add fizz for all numbers containing 3 instead of just those that are multiples of 3? Well, we could either do that by adding a new rule, or we could modify this rule so it returns when number is a multiple of 3, or a number contains 3. We would have to do some string manipulation there, convert it to a string and do substring or something like that, or contains, or some sort of logic there. But we could easily expand. These rules could be much more complicated than what they are. So, um, except for the um, having problems with our bringing in our module functions. Um, I liked how this one went. Um, the So we still have this function still kind of confusing. I think you can't just look at it and know what it does. So there's a lot of stuff going on there. Part of that is the number. So we're adding numbers, and then we're also looping through rules, and that kind of feels like two different things. So that feels like this is not doing this function isn't doing just one thing. It feels like it's doing two things. So I think we should probably split that out. Um, I really like the way our Fizzbuzz and Fizzbuzz Whiz functions end up turning out. Our rules actually are pretty easy to understand, I think. If we were using a language more like TypeScript or something like that, we would give this a type, and so that you would have to implement criteria and replacement and those kind of things. But overall, I think this is an improvement over what we had before. Let's look at our tests. Um, I'm much more happy with our tests now. I think somebody is going to come in and understand these tests better. Um, so yeah, so if we do this one again, we can work on making sure that our number replace um, is um, so that our number generation and our replacement logic is separate. We can um, make sure that we split things up into different files. So we create a module for our base stuff and our rules, and our Fizzbuzz and Fizzbuzz Whiz can each be its own thing. And we didn't bother with the printing out of values, which could be its own thing as well. So um, if we do this one again, maybe we'll want to practice more on modules. Obviously, that is something that um, isn't I can't do it just off the top of my head. So next time we'll work on this, and so um, it can be off the top of my head. So thanks for joining me. Thanks for watching along. Um, what you're seeing is me practicing and learning as I go. So a lot of these kind of things, obviously I've done Fizzbuzz before, but a lot of times I've done it in languages like C sharp. Um, and I've used different libraries and whatnot. So learning these other libraries and kind of growing um, is always helpful. I think we'll probably do this Fizzbuzz one more time. Um, we have a lot more katas that I want to go through, um, but it seems like there's still stuff here to learn. This is a super basic um, kata, but as long as there's still stuff to learn, well, we might as well keep learning it. If you have any feedback, go and leave it in the comments. Um, if you see a better way to do things, or you see a smell that I'm not working on yet, let me know, and we'll tackle it next time. Thanks for joining me.